सेशन स्टार्टेड. ओके, आवाज कमी करतो आणि राईट. So are we online? I can start. Okay. So yeah, मग तुम्ही ते फुल स्क्रीन करून टाका म्हणजे मी सुरू करेन. एक्सलेंट. Okay, it's a great pleasure to welcome you back to this session. I think this is going to be our last session for this course, and I hope you will ask many questions and we will have an interesting session. So good evening, Dhanusha. Good evening, Madhuri. It's nice to see you too in the beginning. You two, I think, have responded to most of the questions and you have raised many important points also. Hello, Jamin. How are you? I hope you are all doing okay. So, even after this course is over, it would be nice to be in touch one way or other. I don't see any questions yet. So even after this course is over, good afternoon, Soumendra. Nice to see you too. We are in the 12th week of the course, and soon, hello Aditya. So soon this course will officially end, meaning at least the our routine of hi Kanu, the routine of uploading videos and assignment sheets and so on, that will come to an end, and then you will have your exam, and as they say, you will go your way, I will go my way, but it would be nice to be in touch. So I have actually also received, meaning the email that informs you about this live interactive session also gives you a Google form where you can put your questions and so on. And in the last two sessions, I had not looked at those questions which were put there by you people, but I have now received them, and I actually took a look, and I am going to answer those. So what I plan is that we normally have 1 hour or so. So I will complete this session, and then in the 10 or 15 minutes, I will quickly talk about the questions which are raised there. So Aditya has asked, will this course help in concepts such as Galois theory, numerical analysis, etc.? So of course, what happens is that often in mathematics, one thing that you learn in any part of mathematics is the various ways to think about problem solving. So once you know about this thing about problem solving, then of course it will help you in many other areas also. But as such, in Galois theory, the flavor is completely different, and numerical analysis is yet another flavor. So, as such, this course will not really help. It would perhaps help you in maybe algebraic number theory or analytic number theory, because you would know what answers to expect in some questions. But otherwise, in Galois theory and numerical analysis, Galois theory is really the pinnacle of the basic algebra, as we call. So, the basic algebra starts with group theory, ring theory, you have modules, then there is field theory, and after that we have Galois theory, where the main theorem of Galois theory, talks about the subgroups of the Galois group and the intermediate field extensions. So number theory as such will not help you, but of course, Galois theory helps a lot in algebraic number theory. where we are going to talk about general extensions. We talked about quadratic extensions, and we completely classified the units. We obtained this explicit structure of the unit group. If you wanted to do it for a general number field, so to say, which is a finite extension of rational numbers, then their Galois theory will be very useful. So if there are extensions which are Galois, if you have a number field which is Galois over Q, then you have a nice structure. Otherwise, the structure is not so refined. So this course will not help you in that, but yeah, meaning the concepts are always nice to learn, and some things about how to go about solving problems and so on is very useful. Numerical analysis is a different ballgame completely. Meaning, numerical analysis is mostly about estimates, finding errors, and various clever methods to do things quickly. So even there, this course will not help. This course may help some people in doing computations faster, but I expect that many of you already are able to do faster calculations, and so I will not say that this course will help you in doing that. Dhanusha has asked, what are the other courses you conduct, sir? So this was my very first course on NPTEL, but I must say that I am encouraged by the huge response that I have received. Not to talk about the 6,000 or so number of students, because I think some students had to take this course as their universities were perhaps not able to conduct courses. But I'm talking about the response that I got on the emails, meaning various people wrote emails to me, and people were not afraid of, pointing out mistakes and asking questions and so on. So that was very nice to see. So I may offer some courses. I'm yet to think about what courses to offer, but I will think about offering courses. Okay, so Muhammad is asking, please tell us about applications of continued fractions. So continued fractions, as I told you already, meaning the pattern in continued fractions can tell about the number, whether the number is a quadratic irrational or not, and it can tell perhaps a lot more because, you can solve the Brahmagupta-Pale equations using the continued fractions and so on. There is one very important thing which is about transcendental numbers. So we have these hierarchies of numbers. There are the natural numbers. Then we have what are called algebraic numbers. So natural numbers will give rise to rational numbers. So rational numbers are the numbers which are of the form p upon q, where q is a natural number, p the numerator, that is an integer. So it can be 0, it can be positive or negative, and we know rational numbers quite well, and anything which is a real number but not a rational number is called irrational. Okay, so this is something that we have already seen, that there are rational numbers, and outside the rational numbers we have irrational numbers. And similarly, there are what are called algebraic numbers. So algebraic numbers are those numbers which satisfy a polynomial over integers. So for instance, root 2 is an algebraic number because it satisfies x square minus 2 over integers. Or if you are taking root of 1/3, that will satisfy 3x square minus 1. Okay, so an algebraic number is something which satisfies a polynomial over integers. It can be a higher degree polynomial. It can be a polynomial in degree 2020 for all we know. Okay, so all these algebraic numbers will still form a subset of real numbers. It's not equal to the whole R. As I think I answered one question yesterday itself, that pi is a transcendental number. So pi is a number which does not satisfy any polynomial over integers. And therefore, you cannot write it as a rational number also. Okay, so pi, which is not algebraic, cannot be rational. Rational numbers is a smaller set. Algebraic numbers is a slightly bigger set than rational numbers. And outside that, we have transcendental numbers. Now, the counting analysis will tell you that rational numbers are countable in number. The whole set of real numbers is uncountable. But the field Q is a countable subset. And a small modification will tell you that the set of algebraic numbers is also countable. So all real numbers, the set of all real numbers which satisfy some polynomial over z is a countable subset. And therefore the transcendental numbers is an uncountable subset because it's a complement of the algebraic numbers in an uncountable set. So it means that if I take a real line and throw a dart, then it's more likely that it will hit a transcendental number. But unfortunately, we don't know many transcendental numbers. Meaning pi is a number that we know, e is another number that we know. But what are other transcendental numbers? Are there some nice transcendental numbers? Continued fractions will help us. Continued fractions will help us get hang of transcendental numbers. Okay, so the continued fractions are going to be very useful to us. In giving also the information about transcendental numbers. So the transcendental numbers are obtained using patterns of continued fractions. I think so. I don't quite recall the statement off the top of my head, but apparently, if there are some nice results on that. And Baker's work actually. So I was talking about the book by Baker, who is a Fields medalist, by the way. So he got his Fields medal for his work in transcendental number theory. And so transcendental number theory has lots of applications of continued fractions. Saumendra De asking, is this course help for CSIR net? Yeah, it may be useful. Why not? Meaning there are often questions on basic number theory in CSIR examination, and this might also be useful. Venkata Subareddy is asking, sir, does every infinite continued fraction converge? Yes, that is what we proved actually. So what we proved is that whenever you take whenever you take an continued fraction expansion, let's say, so you have an infinite nested such expression of continued fractions, then these expressions, the first one will be always a lower bound and the next one will always be an upper bound. And then what you are going to do is that you are going to move like a pendulum. So from the upper bound, you are going to travel to the lower bound. You will stop at some point. Then from there, you are going to travel to the upper bound, stop at some point and keep doing it. And we know that our set R is a complete metric space. So this should have a limit point, and that will be the convergence point of the continued fraction. So every continued fractions expansion does converge to a real number. I hope that answered Venkata's question. So Aditya is asking, apart from cryptography, what are major applications of number theory? Okay. So cryptography is one standard application of number theory that one can think about. Are there any applications of number theory other than cryptography? So it really depends on what you would call as number theory. So nowadays the number theory has expanded its branches. It's like a tree which has outgrown the number theory as was envisaged by maybe Hardy, Ramanujan and so on. So there are these other branches which one may call algebraic number theory, analytic number theory, modular forms, L functions and so on. And there are plenty of applications of these area. If you were to ask about basic number theory, then perhaps there are not. About applications of basic number theory in areas other than these cryptography and so on, I perhaps do not know any of broader set of branches. Then there are plenty of applications. You perhaps may know that modular forms have a lot of symmetry and they encode quite a lot. So there are supposed to be some modular forms which encode information about our universe and so on. So there is quite a lot of application, but maybe basic number theory there may not be. Danish is saying, sir, I hope the questions in the NPTEL final exam are uniformly distributed across all chapters. I plan to concentrate more on the units I feel easier for me. That's why I am asking this. So Danish, If you are going to leave some topic, if you are going to pick and choose, then that's always a risky thing. And you have been warned. So that's the only thing I would say, because there are finitely many questions. And although there are some major themes in our course, and what I have tried to do is that each theme has a sizable contribution to the final examination. But ultimately, one cannot say that each theorem should be represented, or each particular set of examples should be represented. That would be very difficult to achieve. So I have tried my best. Of course, this is what one would expect, that the examination should be well distributed. We should not concentrate it only on, say, continued fractions, and we should not concentrate it only on congruences. It should have roughly everything, and that is what it does. It has roughly everything, but only roughly. Shreyas Kulkarni is asking, is the final exam subjective or objective? So I was thinking that, I would send an email out, maybe this weekend or so, giving some information about the format of the question paper. It's mostly objective. There will be some fill in the blanks type. So objectives would mean often that you have to choose from the given options. But here in this case, you may have to write the final answer in the blanks which are provided to you. So it is objective in that sense. So Dhanusha is again asking that Fermat wrote a letter to Pascal that every natural number is an at most k-gonal numbers. Indeed, that's what Fermat wrote. And it's not clear whether he proved it or not. Those days people used to write to each other telling about the results that they have obtained. And, often in the excitement, one may think that one has proved some result and one may shoot off a letter. But later one may think that, oh, the proof has some mistake. And so one may not feel like rewriting to Pascal saying that, that particular theorem is not quite true or so. Or maybe Fermat was very busy. Fermat was also a judge by profession. So he must have been doing number theory in his spare time. And that may mean that he used to have a lot of spare time. But anyway, so it's quite natural that he may not have thought about this very deeply. He may have only thought about it as a conjecture. I would think that he made it as a conjecture. I have not seen that paper, by the way. I only saw it somewhere that Fermat wrote about this. I don't know whether he meant it as a conjecture or whether he meant it as a result that he had proved. I should also say that conjecture is a modern word. There were no conjectures then. So people would, of course, Gauss and so on would think, but making a conjecture is a serious thing. And people would talk about a statement only after they have a proof. So that's my impression. So people would not make conjectures. They would simply prove results. Sir, say more about polyhedral numbers. Sorry, Dhanusha, I don't know anything about these polyhedral numbers. So by polyhedral numbers, I mean that you are asking these 3-dimensional, 4-dimensional, and higher dimensional polyhedra and the number of lattice points in them. I have no idea about it. Maybe I should do a course on recreational number theory, and then these things can be taken up. We will see. Soumendra is asking what types of questions will provide in the final examination. Same as assignment, any theory, broad or short type. So I will not be asking theory type questions, because you will have to write the answers and then somebody will have to go through the answers. And with the 6,000 plus students, I cannot ask my TAs to go through. We don't know. We had no idea how many of you would register for the final examination, but we did not want to take risks. So there are no long answers. The answers are short. The answers will be either, choose from the given options, where there can be multiple options which may be correct, and then you have to choose all correct answers. Or there could be true or false type questions without any justification asked. And then finally, there will be questions where you will have to write the answer in the given spaces. So these are the questions which are there. Naveen Kumar is asking again, request you to please tell us about application part of number theory. So, I have already talked about this. Aditya had asked a question, and so cryptography is one particular application of basic number theory that one can think of. But other than that, number theory has lots of applications, and they proliferate in almost every branch of mathematics. Venkata Subbareddy is asking, sir, can you suggest any book to study completely about partitions of a natural number? So, there are books. So, in mathematics, there are many book series, and there are books which are called mathematical encyclopedia or encyclopedia for mathematics. So, the exact title beats me right now. And there is one book called partitions. So maybe you should search for handbook of partitions. You should either search for encyclopedia on partitions or you should search for handbook, HANDBOOK, handbook on partitions. But I must warn you that these are very thick books. So these are the books which will contain almost everything that is there on partitions. And if you really want to learn a lot about partitions, then these are the books that you should perhaps look at. So Santu Datta is asking, sir, can you suggest a book on India's contribution in number theory? Can you take a session on this topic? So I am not going to take a session on this topic, in the NPTEL, because I will have to see whether there was already a course offered in NPTEL about history of Indian mathematics. I will have to check, and if it is not, then I may think about taking such courses, perhaps. Maybe a short course, a 6-week or 8-week course, not a full 12-week course. That is what I may think about doing. This would be perhaps another possibility of a course that I may take later in NPTEL. And about a book on India's contribution in number theory. So recently there has been quite a lot of activity about India's contribution in mathematics in general. And in IIT Bombay, one of our colleagues, Professor Rama Subramaniam, has been a scholar in this. And he himself has edited several volumes and he has also written several articles. So you should perhaps just search for IIT Bombay Ram Subramaniam, or you should search for IIT Bombay History of Mathematics, and you will get lot of references from there. Aditya Vaidyanathan is again asking, sir, is there any idea about internships after completing this course? So, it's not clear what you mean by internships. If you mean in institutes, then you should perhaps write to people and ask in those institutes whether they are willing to offer internships and so on. But what you would really need in all such internships is to have a good recommendation letter. I may perhaps take this opportunity and inform all of you about these things. So we routinely receive several emails about internships or summer projects and so on. And we have to pick and choose, not just for offering internships and so on, but even while replying. So if I see an email where my name is put in the BCC and email, it would be best if the email is directly addressed to me, dear Professor Garge or dear Shripad or whatever you may call, but you should address it directly to me. Then I promise to give you an answer. But if the email is not addressed to me, often we receive emails saying, dear sir / madam, and then the email is either sent to several people at one go. Then I will feel not obliged to answer to such an email. Or if I see that my email address is in BCC, then I would assume that there are possibly other email addresses in BCC, and then I am not obliged to answer. So this is the general advice that you should take. If you want to get something from somebody, at least be courteous to write a direct email to that person. Okay, so that's what you should do. And another thing that you would really need for getting internships or summer projects is to have good recommendation. And having a good recommendation from somebody, you should at least do 2 or more courses with the person. So, meaning many of you have done well perhaps in this course, but I have not actually seen. Many of you have discussed with me personally. So I have some positive opinion about you, but I will still not feel secure enough, sure enough to write a recommendation letter for you. So if you are just going to tell others that you have done this course with this IIT Bombay professor and you have got this grade, and if they are willing to offer you internship, that would be great. But often what is needed is that you should have good recommendation letters. So you should try to, discuss more with people, and then get recommendations and then go for internship. So alone this course perhaps will not be enough, but it may help you to some extent. It would of course have helped you in learning number theory, and it may possibly also help you in getting internships. Dhanushya Raghu is saying Fermat's last theorem does not come under number theory, or it does come under number theory. Why do you not say that? The statement is, of course, from basic number theory, and the proof and everything is part of number theory. You will not see Fermat's last theorem as part of any analysis book. You will see Fermat's last theorem as part of number theory books. So Fermat's last theorem does come in number theory. He is again further saying simply studying about proofs for Fermat's last theorem gives more on number theory, right, sir? Yeah, that is true. Actually, so you know that Andrew Wiles has proved Fermat's last theorem, and if you read his two papers in Annals of Mathematics, there is one whole issue of the Annals of Mathematics containing both the papers. The first one, his own paper, and second with his former student Richard Taylor. So those two papers, if those are apparently very readable. I have not really gone and read them because my interest in number theory is slightly separated from Fermat's last theorem and the mathematics which is used in proving the theorem. But if you go and read those, and if you can understand, then you can surely say that you have mastered number theory. That much you can certainly say. So reading about Fermat's last theorem and understanding it will definitely mean that you have learnt number theory. Muhammad is asking why something something is a convergent to something something in solution of assignment 11 question 9. So Muhammad, why don't you wait? Meaning the detailed solutions are normally uploaded by weekend or so. So why don't you wait till weekend? Anyway, you have been writing on the email forum. Why don't you write there? Here maybe we can discuss something more. By the way, I should tell you how I got all these options. So what I have done is that pi, I have cut pi at some level, right? So I have got some huge number, 3.14 blah blah blah, and it's a rational number because I have cut it at some point, and I simply wrote the continued fraction expansion for the continued fraction for this rational number, and then I erased some parts at the tail. That's how I got all the convergents, and those are the only ones which I have given here. So 3 plus pi would be 6.1519 something something, and then I obtained the continued fraction and then erase the parts. That's the way I have got these numbers. So maybe if you do that, then you would be able to see that. Yeah, by the way, so okay, I read your question now carefully. You are asking whether it's a convergent to 3 plus pi. That's not what I said. I have said that assuming that pi is that. Okay, so really I am going to look at this rational number 651 upon 106 as a convergent to 6.1514 or whatever 1519, that rational number that we have obtained. It's a convergent to that. It need not be a convergent to 3 plus pi. Rucha is asking, will proofs be asked in the final exam or is it fully online? This is fully online final exam. Proofs will not be. Long answers are not asked. No essay, no proof. So Mohammed is still continuing with. So Mohammed, I think we should both sit down sometime and do this calculation. This is perhaps not the correct time to discuss these things. Okay. Danish is again asking, why would they conduct this course exam every cycle? I do not want to sound pessimistic, but just in case failure, I really want to crack this exam one day or another. So Danish, this exam I believe is conducted every time the course runs. So I don't know if this exam will be conducted again next time, because they will perhaps not have somebody to set the exam or to grade the exam. So anytime the course runs, the exam will be conducted. Apparently there is something called possibility of a rerun. So a course may run again, and meaning it means that I may take this course again sometime down the future. I don't know when. And in that case, you may be able to give the exam again, but then you will have to again register for the course, give all the exams, all the assignments, and then give the final exam. Mukta is asking, sir, is number theory and real analysis related? So, of course, meaning Mukta, I think since you are a Marathi person, at least from sound your surname, you may have heard about what is called Badarayan Sambandha. So, there is this story that if you really want to say that two things are related, then you can one way or other make them related. And the Badra and Sambandha is about some story from ancient times about how somebody just, became a guest in someone else's house, stayed there for a very long time, and ultimately the hosts realized that this person who had come to stay in our house is not related to the husband, neither to the wife. And then in the end, they asked the guest as to what was our connection. And he said, oh, well, the bullock cart that I used has the wheels made from certain type of tree, and the same type of tree is there in your courtyard also. So, just somehow you try to make two things related. So that could always be done. But in number theory and analysis, there are many interesting relations. So analysis, real analysis, you may think about, completing the metric space. So you have the space Q, rational numbers, and we have the usual metric on it, which is the modulus of the number. And the distance function is given by distance between 2 points is the modulus of the difference between the 2 points. And this Q has many holes, as we know. And so we plug those holes to make it a complete metric space, and we obtain the whole set of real lines. Now there are many other metrics that can be put on rational numbers using the prime numbers that we have. And these are called p-adic metrics. And then you have a completion with respect to those metrics. So those will give a slightly different, actually a completely unimaginable type of geometric space, which is called QP. So here you have R, which you obtain by completing the rational numbers with respect to the usual metric, the modulus. But you can look at the p-adic metric and complete rational numbers with that and obtain what is called QP. Those are also complete metric spaces. Those are also fields, just like our real numbers are. And those are very interesting fields because some of them will contain imaginary numbers. Sometimes you will have a solution to x square plus 1 in some QPs. So those are all subsets of complex numbers, but they are situated, in some way. They are embedded in complex numbers in some way. And then there is a very important result which is called local global principle, which talks about quadratic forms having a root in Q is equivalent to the quadratic form having roots in all these completions. So let me say that again. Suppose I have a quadratic form. So I have some n-dimensional quadratic form. It will be, say, a0 x1 square plus so a1 x1 square plus a2 x2 square plus dot 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 an xn square. Okay, so here I am taking only the diagonal quadratic form. We are not taking xi xj, but let's say that we have all those. So we have summation aij xi xj, where I and j go from 1 to n. We have a quadratic form like this, where the coefficients aij come from rational numbers. Now, one question is, do we have a zero to this quadratic form? Are there non-trivial zeros to the quadratic form? And the solution is that if you have a non-trivial zero in rationals, of course, the same will be a zero in reals and it will also be a zero in QPs. But the converse also holds, which means that if you have a zero modulo for each QP, and if you have a zero again over rational numbers, then you are going to have a zero over rationals. Let me say that again. If you have a zero over all QP and if you have a zero over reals, then you have a zero over rationals. So this is called a local global principle, and it is very useful not just in number theory but in many other areas also. So what are called principal homogeneous spaces and so on. So this is something which is a very useful concept, And it began with some very simple relation of number theory and real analysis, the metric spaces and so on. Pallavi is asking, for example, cryptographic concepts, Einstein numbers, Fermat Mersenne primes, elliptic curves, other areas of Diophantine equations, etc. I don't know, Pallavi, what examples are you suggesting? Maybe these are the. Okay, I missed your earlier question. Can we have a follow-up course next year on some of the other slash advanced topics from elementary number theory? Look, this course has been tiring, meaning it was enjoyable, but it was tiring because I also had to do my regular course here at IIT Bombay. So I don't know if I am going to take up any course immediately next year. Actually, I know that I am not going to take a course immediately next year because the process of having a course starts much earlier than running the course. What we have to do is that we have to give a proposal to NPTEL. So I will typically, I will tell you what I did for this course. I wrote down a syllabus. I sent the syllabus to NPTEL saying that this is the course that I would like to have. I also gave some names of mathematicians in this area, number theory, and then I would assume that the syllabus that I have proposed is sent to these people. They look at it and they perhaps give their opinions on that, and then the course gets approved. Once the course is approved, then we typically spend 3 to 4 months to get the videos recorded, and only after that the course will start. So next year I am not going to start the course simply because I have not even given a proposal. But I may later take some courses, and indeed these are the suggestions that I will keep in mind. These are very interesting suggestions. Saumendra is saying, Dhanushya is saying he could understand proof of Sophie Germain, but when he looked at Wiles's proof, then he had a bit of difficulty. Indeed, Wiles' proof is more advanced. So that is quite understandable. It uses elliptic curves and so on. I must also say that there are many other basic expository books now available on the proof of Andrew Wiles. So you may want to take a look at them also. Of course, you will have to learn what are called elliptic curves. You will have to learn what are called modular forms and so on. However, I will suggest this thing to you that you may take some statements as black boxes. So, people often complain that group theory was a prerequisite to our course, although it was called basic number theory. But if you were to take some subjects as some statements as black boxes, saying that some particular statement is simply accepted, you will not go back and try to see whether that statement has a proof and so on, but you accept some statement and use that to prove results in number theory, then that will enable you to learn number theory faster. Of course, there will be some assignment problems which you may not be able to do, but that's okay. Meaning, how many exams have we had where we got 100% of marks? Getting 100% of marks is very good, but it may not sometimes be possible. There are, of course, some questions in assignments which are going to differentiate people who may know slightly more and who may not know. And so meaning although group theory and of course our assignments were uh, of the type where only the top 8 scores are going to be considered, so even that is not a problem really. Asking some of the group theory type questions, the unit groups of modulo sum integers and getting information about them. But even then, even in those, I think we had only used the prime factorization of the numbers, so even there perhaps there should be no complaints. But anyway, so this is something that I will tell Dhanushya because he has asked about this proof of Andrew Wiles, that there are some statements from elliptic curves, some statement from L functions, something from modular forms, or something from Galois representations. Those maybe you should take as black boxes and then try to understand the proof. There will be some concepts which will be used, and for that you should perhaps have some exposure to the areas that I have mentioned just now. But I would also say that if something is very difficult and you want to understand it, then you have to go through it many times. Meaning, I know of some great academicians who have told me that understanding a book, although it might be some simple book, if you want to understand the book, you may have to read it more than once. Meaning, I'm not talking about some novel or a story book, But if there is a book on philosophy, let's say, or if there is a book on something, and you want to understand the book, then it is often helpful to read it twice. If you are reading Bhagavad Gita or something, the more number of times you read it, the more things you understand. So you have to go read it, meditate on that, and then again read and keep reading. And then ultimately the proof will come to you. Suversla is asking, is there any easy method to check convergence? Which method is mentioned in the lecture is very calculative and takes too much time. Yeah, so there are necessary conditions that convergence should give you good approximations. If the rational number is not giving you good approximation, then it cannot be a convergent. That we already know. But other than that, I do not know how one can find convergence. Maybe there might be some online tools which you may use. I don't know. One will have to search for that. I expected that you people will have calculators, and using calculators you will be able to do it. So I gave some calculative problems. Soumendra is again asking, will you start any courses in real analysis, abstract algebra, and linear algebra in NPTEL platform? I want to participate in these courses. So I think, these are basic topics, and almost every year there are courses on this area. Although I will not be able to take any of these in the coming years immediately, but there are many good teachers I know from my IIT and also various other institutes in the country, that people are taking good these courses. And until you enroll in these courses, you will not know how good the courses are. So go ahead and enroll, and we will see what happens later. Is there any, he is again asking, is there any course for CSIR NET exam which is conducted by you? No, I'm not giving any course on CSIR NET examination. I think, my suggestion for CSIR NET would be that you take some last 6-7 years question papers, solve them or get them solved by some experts, and that will give you some idea on how these exams are held, and that should be enough for you. I would actually, I will tell you the time when I gave these examinations, I had only learned about these topics from certain fixed books. And luckily, our master's syllabus was quite good. So I learned algebra from the book of Artin. Michael Artin has this book on algebra. That's the book for algebra. I learned topology from Moncrief. I learned analysis from Rudin. And what are the other areas? So functional analysis from the book of Limaye, who was our colleague, but he is now retired from here. And I think these are the only areas that I had really prepared, and I could get CSIR NET. So if you are really keen on for differential equations, we had this book of Coddington, maybe Earl Coddington. That was quite good. I did not do anything in differential equations after my master's, so I don't recall the title of the book. These are some standard books which have a lot of problems, and you should have problem solving skills to clear CSIR examination. So I think that would be quite useful. I think, yeah. Shreyas is asking, sir, by rerunning of the course, do you mean that this year exam may get cancelled and we may need to do all the exam assignments again? No, of course not. Shreyas, don't worry. The examination will be held as the schedule that is announced, and you will all get grades. You won't have to do it again. Of course, what happens is that when we have a course on NPTEL, then the instructor and the team puts in a lot of efforts, meaning we prepare videos, we prepare assignments, we prepare examinations, and so on. And it is often felt that such an effort should not go waste. So NPTEL gives us an opportunity to run the course again, maybe a few years later, so where we may use the same videos, maybe with some small changes, and we get the opportunity to go through the assignments once again. And many of you have possibly pointed out several mistakes which were there, so we will correct them. We will perhaps tweak the assignment problems here and there, and have a new set of assignments ready for the course, and have the course again for fresh students. That is what is meant by rerunning the course. And so that's what I meant. But I am not, of course, going to suggest that we cancel this course. I mean, you all have put in lot of efforts, and so have I. We are not going to cancel this, don't worry. So Danish is saying, I have exams on discrete mathematics course and number theory exam on same day. Hope you understand the difficulty in back-to-back exams of two largely divergent subjects. I do understand it all. I have my best wishes from the bottom of my heart. Since he is further asking, since you have access to NPTEL, please let them know the difficulty. I do not know where and whom I can speak to. I find you as very student friendly. Thank you, Danish. So I am telling you this, but I cannot do this. I am student friendly, and for being friendly to students, I cannot tell anybody to reduce the difficulty level or any such thing. If you are asking me whether the NPTEL exams can be scheduled on a different day or something, that is not within my hands. Those schedules are announced already, and I think, because people have to come from different places to give the exam in the center, I think it is best that they are held together. And of course, meaning if you are going to prepare for the discrete mathematics and number theory, you have been preparing for this throughout the semester, right? We are not preparing it on the last night of the exam, and don't tell me even if you have been doing it. So, having these two different dates and so on it's not within my hand. Mohammed is saying, is computing the Jacobi symbol for the big composite number difficult because factoring is a difficult problem? Yeah, meaning many of the problems are difficult because factoring is a difficult problem. But we have if those are odd numbers, then we have the quadratic reciprocity law for Jacobi numbers also. Just like we have the quadratic reciprocity law for the Legendre symbol, we have the quadratic reciprocity law for Jacobi symbol, and that should help you. So that's a way to compute Jacobi symbol. Dhanushya is saying Indian contribution on number theory is not note. No, I did not say. So Dhanushya is saying you said Indian contribution on number theory is not notable. That's not what I said. Of course not. Meaning in my lectures, I have talked about Indian contribution on number theory, the modern contributions by Chawla and Balasubramaniam, and I also talked about Manjul Bhargava, whom we can claim as our Indian mathematician. And even before that, I have been talking about Brahmagupta and Hemachandra and so on. I would not say that the Indian contribution to number theory is not notable. It is notable, and all that I am saying is that earlier there was no recognition for that, but now slowly there is recognition for that. Then even Vedic mathematics has no contribution to number theory, sir. Vedic mathematics is a separate thing. Vedic mathematics is it's not really a subject. It's a part of mathematics. I would agree to that. And what it does is that it will help us solve problems in some simpler ways. But it's not going to be something which would, help you in learning number theory or so on. It may perhaps inspire you to find more ways to solve problems in a quicker way, nicer ways. But as such, on the nose, it's not going to help you in solving number theory problems. Thank you, Pallavi, for the kind words. Madhuri is saying she watched Manjul Bhargava sir video. He said anyone does mathematics for the same reason anyone does art. How I did not understand, as in art has no fixed definition of right and wrong, but mathematics has. Okay, so we should go and ask Manjul about it, what he meant by that. But meaning this is what people have been talking about. So let me give my perspective on this. If you see an artist doing anything, an artist will not do it because somebody appreciates the art. The artist does something because he wants to do it. Meaning, if you have traveled through, in your travels, you would have seen that some people just sit down with pen and pencil and they start sketching something. Or if you go to a seashore, you will see some people sitting with a pad and trying to draw the sunrise or sunset and so on, and maybe the hills, the people playing on the beach and so on. So they just do it because they want to do it. They like doing it. And it's not that there is any incentive for them to do it. They are doing it because they like it. So that I think Manjul also perhaps meant in the same vein that people are doing mathematics because they like to do it. I would actually go further and say that people do basic research, not some advanced engineering things where you can how you can devise a new car or what new type of fuel you can perhaps invent and so on, but basic research. People do basic research because they like to do basic research, although there may not be incentive. So you may be simply, some lucky ones like me get to be in IIT Bombay, or some other people, they have to teach in colleges and so on. But when they go home and they take pen and paper and start thinking about this basic research, that's when they are very happy. So people do things because they like it. People do mathematics because they like it, just like artists, um, express themselves through art because they like doing it. So I think that's what Manjul means. So Dhanusha is really, holding me to all the statements that I am making. He says that then you say without having any black boxes, I can't understand the proof of Andrews. No, I am not saying this because, to be frank, I will have to know what you know and what you don't. If you know all the elliptic curves and everything, then you would perhaps have ability to follow Andrews' proof with some difficulty, because even people who know elliptic curves and modular forms may understand Andrews' proof, may find the proof to be difficult. It's a proof of a theorem after all, and in the proof, often all the steps are not really explained. So all the major steps are given, and often even in understanding a proof, one would want to know how the person thought about the proof. Even that may be difficult sometimes in the areas that you understand. So I am not saying that you will, first of all, I am not saying that you will have to take black boxes, because I don't know how much you know about these areas of mathematics. Secondly, even if you don't have to take black boxes, I am not saying that the proof will be simple. The proof may still be difficult even if you understand all the areas which Andrew Wiles is using. So, understanding a proof is a bit of a different thing. And what I was trying to say was to be helpful, because you said that you could understand Sophie Germain's proof, but you were not able to understand the proof of Andrew Wiles. So I said that sometimes it may be useful to take something as a black box and then go ahead and see what you can learn from taking this statement. After all, logic is about seeing whether one statement follows from another statement. That's what logic is. And what mathematics is, in some sense, is the set of is logical sequence of statements which constitute the proof. Mathematics is about proving theorems and writing statements in a logical sequence, which will then imply the statement that you want to see. But everybody may not follow the same logical pattern, and so there might be different kinds of difficulties that one may have. Mukta is asking, sir, if we are referring to any mathematical books, is it important to be able to solve all the exercise problems? No. My personal experience is that I may understand a topic, but yet I may not be able to solve all exercise problems. I would want to. I would want to solve all exercise problems, but some problems are simply difficult. In fact, there is this mathematician by name Serge Lang, Serge, Serge, and Lang, Lang. He has lot of books on many nice areas of mathematics. So I think he has a book on complex analysis, and in one of the chapters, the Riemann hypothesis is given as an exercise problem. Now, how would, meaning, if you solve that exercise problem, then you have proved Riemann hypothesis. Or if you have disproved that problem, it would mean that you have disproved Riemann hypothesis, which would be a great thing. But so far, there is nobody who has solved or proved or disproved Riemann hypothesis. So we may say that there is an exercise in Lang's book on complex analysis which is not solved yet. But there are people who are experts in complex analysis. So of course, I will not say that solving all exercise problems is a must to have understood the subject. But still, we should all, we like to always check how much we know. And so it is important that you try and solve as many exercise problems as you can. It's also nice actually, if you solve some problem, it gives you a good feeling. So solving problems is good, But if you are not able to solve some problems, then it's okay. You may keep them away, maybe read further chapters and then come back to solve them. That is something that you can do. Or you may discuss with your friends, you may discuss with your batchmates, you may discuss with your professor and see whether that helps you in solving the problems. Dhanush says again, should I take elliptic curves, Fry's curve, and modular conjecture as black boxes? Of course. So modular conjecture needs to be taken as black box. Modular conjecture, by that I hope you mean the Shimura-Taniyama conjecture. That should be taken as a black box. I think it is proved recently, but I don't know in what generality it is proved. Phrase curve is it's a one single paper. Maybe I think that is something that you can read. And elliptic curves is a big area once again. So elliptic curves is something that you may have to take a black box. Of course not. Don't be sorry for asking questions. Don't worry. All right. So Pallavi is asking, does the Conway 15 Bhargava 290 proofs also implicitly prove Ramanujan's list of 54 universal forms? Yes, it does prove that. In fact, I think Ramanujan had a mistake. There were some forms which were perhaps, I think one form was listed twice and some forms were should not have been there and one or two forms were missed out. So they have corrected it. So I think the Conway 15 proof will be enough to prove Ramanujan's list. Sahia Rias is asking, please explain how to find convergent to a continued fraction by an example. So, I cannot use calculator or pen paper here, but what you should try to do, meaning depends on what you mean by continued fraction. If you have a finite, continued fraction, that means you have a rational number. Then what you should do is that use a calculator and be careful about all the things. We may make mistakes, and making mistakes is what will give us wrong results. So be careful about that and just be patient. Meaning, what I find these days is that many students, even here in IIT Bombay, they want to find short answers. They want to solve short answers. They don't have patience for writing long answers. But I think this is what we should have. We should be able to do long calculations, and these are the things which are not that long, really. Okay. Dhanusha is saying, I am more interested in number theory. What other topics should I cover after what you taught? So, meaning reading Baker's book would be a good idea. Doing algebraic number theory, analytic number theory, that's a good idea. I think what you should try to do is, so there are two possibilities. Either you are interested only in doing number theory for the sake of learning, and then you are free up to your choice. But if you want to do research in number theory, then maybe what you should plan to do is to join some research institute. And so you should look at research institutes in mathematics in India and abroad and see what things people are doing and then focus on one of those areas. That is what I would think. You should fix your aim first, and then accordingly you should choose your things to do. Soumendra is saying, after completing this course, can I conduct with you for the problem in mathematics? So you perhaps want to ask whether you can write emails to me and get answers. So you can, of course, do that, but I will not be able to give answers to each and every problem that you may have. I may give you a hints to get some solutions, and sometimes I may not even be able to do that. Some of the problems may be very difficult for me, so there is no guarantee. Specifically for net exam, I think, for net exam, you should be able to get help from your local teachers. Getting a help from somebody like, from IIT Bombay is not really very nice thing. What is the next season course about number theory? I don't know what you mean by next season course about number theory. You are perhaps asking whether about the next possible course in number theory that will be offered here. I have no idea. You will have to check NPTEL pages and see what are the next courses which are coming up. Whether calculator is allowed in the final examination, that's a very relevant question. I think since this course exam is online, that means you will go to this NPTEL center, you will be sitting in front of a computer and you will be writing answers by typing out in the browser. And I think they will make an online calculator available to you. So there will be a calculator which will be made available to you within that computer, and you will also be given a pad. So you should carry your pen, and I believe that you will also be given a pad where you can scribble and do some hand paper pen calculations there. So those are the things which are allowed. Abhijit Bhattacharya is saying, please say something about the epic proof of ABC conjecture. What do you mean by proof of ABC conjecture? It's not yet proved, no? ABC conjecture has not yet been proved. Meaning there is a Japanese mathematician has claimed to have a proof by what is called inter-universal Teichmuller theory and so on, but I don't know if that is accepted by the community as a proof. So that paper is accepted, by the way, in a journal where that same mathematician is in the editorial board. But the mathematical community at large has not understood the proof and therefore has not accepted the proof. So, it's a different thing to say that some statement is proved because the person thinks that he has a proof. But the whole community should accept the proof. For instance, I will tell you this another example, though I don't have many details. So I hope Dhanush and other people who are very careful about my statements will not pin me down to any of the statements that I make. But there is a mathematician by name Alex Hales, Hales. So he works in discrete mathematics and he proved what is called Kepler conjecture. So now don't ask me what is Kepler conjecture. It's about some sphere packing and so on. He proved this conjecture, which was supposed to be a very difficult conjecture in discrete mathematics. And he submitted it to the Annals of Mathematics. Annals of Mathematics, the journal sent it to some referees, and the referees worked very hard to understand the proof, but they could not understand it. Okay, the referees where Annals of Mathematics had sent this publication to, this paper to, they were not able to understand the proof. At the same time, they were also not able to find a mistake. So that was a very tricky situation. They could not find a mistake and they did not understand the proof. So they were not sure it was correct and they could not prove that it was incorrect. So Annals of Mathematics, the editors wrote to Alex Hales. Of course, this reviewing process took some time. I think it took 2 or 3 years or maybe more. Even for the usual standard of Annals of Mathematics, it took long time. And finally, the editors proposed one way to Hales, saying that we will publish the paper, but we will say put a footnote saying that this proof is not verified by our referees. They said we will publish it with this footnote, and Hales refused. He said, no, I will submit it to a different journal and I do not want to have it published in your journal if you cannot find referees capable of understanding my proof. So I believe he sent it to another journal and that journal could find referees and those referees understood it and finally the paper was published. So, what happens is that a proof being some statement being proved has to be also accepted by the community. And I am not sure that this proof of ABC conjecture, which is claimed by this Japanese mathematician, is accepted by the mathematical community yet. Maybe this is what you wanted to hear, Abhijit, but this is what this is. Soumendra is again saying, if you permit me, then I will send the problems. Of course, send the problems. All right, so I think it's more than 6 o'clock, and what we should perhaps now do is to look at the Excel sheets that I had received. So Dhanush is again asking, I can't join as your student, sir. So what do you mean by Dhanush joining as my student? If you want to join IIT Bombay for a PhD, why can't you join IIT Bombay? Meaning you can, IIT Bombay has an entrance examination. You should write that entrance examination. There will be an interview. You should clear that interview, and then you come here, and then we will see what to do. Meaning whether you can work with me. Maybe after you come here, you may find that somebody else is better to work. So why not? Uh, no one is stopping you from working with me. Okay, so I go to live interactive session one, where the questions were asked, and I think questions, I will just read out the things, and if there are no direct questions, then I will perhaps not say anything about it. So the comment is by somebody, by Miss Jayashri, is asking recent trend concepts in number theory. So this is just a keyword, and I suppose I am expected to say something about it. So recent things in number theory are quite a lot: Galois representations, elliptic curves, L functions, the values represented by Riemann zeta functions, values of L functions, and so on. Those are the things that we have. Then Shakti Singh is asking, I want to ask how we write elements of congruence class A power congruence class B. So I had given this as an example to say that the congruence class A power congruence class B is not a well-defined concept, because if you want to write this congruence class A power congruence class B as the congruence class of A power B, then you do not get a unique answer. So I have given examples in the class about this, and so I said that we cannot write this. Ashok Kumar is asking, what is number theory? Number theory is study of numbers. Ajit Singh is asking, can I get lecture notes of this course? And is also appreciating my teaching style. So thank you for that. Lecture notes, I believe I have made some copies available, and I am working on the lecture notes, and they will be available perhaps on my homepage sometime soon. Kemlin, Gamlin, no. Karuna Rajkumar, she is asking, how can we tell the polynomial does not represent any prime for natural number? That's because you may take the polynomial to be a constant polynomial, with the constant being 4. So f of x equal to 4 for every x, that's a constant polynomial. Now there is no prime represented by that. So the important thing is to often think about complex constant polynomials also. So Chinese remainder theorem is something that Gamlin has asked, but he did not provide any more details. So I will not answer that. Mohammad Mehran is saying D Pharma. I think he was in the wrong course. Congruence relation is what Pooja Hingmire is asking, but I think I have talked enough about congruence relation. Muhammad C is asking, what is the evaluation strategy of multiple selective types of questions for this course? Can we get partial credits if the question has 2 right answers and we have selected only 1 right answer and none of the wrong answers is selected? So what happens is that often, I want to discourage students from, stopping after you reach a correct answer. What I feel is that you should check all options, and this is why I like this NPTEL strategy of giving all marks only if the all correct answers are chosen. And so I will not think about this another possibility. So Shripad Shevakar is asking, can you please provide detailed solution of assignments? I think I have started doing it now. So assignment numbers, these detailed solutions for 5, 6 were uploaded recently, and 3, 4 should also be get uploaded. I have sent it to the NPTEL staff. So then we are left with 1, 2, and with that will be done by this weekend. Please provide us with some problem sheets for practice. This is again the same person. So, I talked about some of the books even in my live sessions and on some emails. So maybe you can look at those books and look at problems. I will not be able to provide problem sheets. You will have to work on that yourself. How can we change? That's a very interesting question from Dhananjay. How can we change our daily routine life using number theory in day-to-day activities? I I don't know. That's a very interesting question. I am honored that you are asking me such questions, which can change, which can affect your daily routine life. But I have no idea how you can use number theory to do that. What are the job? Okay, so Satyam Jaiswal is asking what are the job aspects in the field of civil engineering during this time of pandemic? Sorry, boss, I don't do civil engineering. Uh, Rajendran is saying in assignment 2, I have doubt for question number 5. So luckily, I have all the list of assignments here. Let me just quickly look at assignment 2, question number 5. Okay, so this is about which of the following sequences of natural numbers will not contain infinitely many primes. So, if you remember, this was about we had stated the Dirichlet's theorem on infinitude on primes in arithmetic sequences. And what we really needed to check whether the a n plus b, whether a and b are co-prime or not. If a and b are not co-prime, then we are not going to have infinitely many primes in that sequence. That is all that one had to do. Nimisha Shetty is asking if the GCD of A and K is 2, then there are at least two natural numbers satisfying A n congruent to 4 modulo K. Yeah, meaning we have seen that AX congruent to B mod n, the number of solutions modulo n is the GCD of A and n. Okay, so once the GCD divides the constant term B, then you have the GCD many solutions. And here what we have is that the constant B is 4, the GCD is 2, 2 divides 4, and therefore you have two solutions modulo K, but then, meaning you have infinitely many solutions given by the congruence class. And so there are at least two solutions. Once you have infinitely many solutions, there are two solutions. Ankush is asking whether 0 is a natural number. 0 is not a natural number. Saumendra had asked this question in that list also on the book to follow for this course. So, I have given some books, but if I remember correctly, I think you wanted to know whether there are any Indian authors having written a book on basic number theory, to which my answer is that I don't know, and perhaps there is none. And his further question is after completing this course, he would like to learn about group theory, ring theory, field theory. So go ahead. There are, I would recommend the book of Artin. That's a very nice book and it should be useful to you during these further endeavors. So that completes our live interactive session 1 questions. And meanwhile, here Suvershla has asked, please suggest any teacher abroad to do research in number theory. So I think what you should do is that maybe I will, first of all, I cannot officially online where things are getting recorded. I cannot suggest any name like this because I may miss out some obvious names and then it's not good. But what you should do is that you should, try to contact people and see where you can go or look at research papers of some people and see whether you can follow them. And finally, the decision is to be taken by you. Meaning, I may like somebody, I may say, go and talk to Manjul Bhargava, but you may not like Manjul Bhargava's work. And then it will be of no use to you. So, what you should do is that maybe do some slight homework and look at what people are doing and see whether you like those things and only then think about working with them. Okay, so I am now in live interactive session 2. Mohit Roy is asking, saying that he is a student of class 8, 10 and doesn't have any knowledge of group theory or ring theory. So I have to go through each lecture twice or thrice. And I am still in week 4. Will the course be available on Swayam platform after the 8 weeks are over? So Mohit, this course is now available for the eternity. Meaning my lectures are available on YouTube and they will be there. No one is going to take them down. So you can read these lectures on YouTube. You can read these lectures on the course webpage also. The whole set of lectures are going to remain available and, meaning the assignments and so on, because many assignment solutions and everything are uploaded in the PDF format. You download them and keep them with you and that should now then be with you for eternity. So it is with you all the time. Raghav Dodla is asking that he wants to be a theoretical physicist and wants to know implications of all these number theory, graph theory, and all other advanced stuffs in mathematics. Could you please explain it to me in brief as to what I should be focusing on this course for the above mentioned purpose? So I'm not, Raghav, I did not conduct this course so as to enable you or anybody else for anything specific. I conducted this course simply because I wanted people to learn number theory. So in fact, some more people had also written emails to me and asked me, saying that they want to do something specific. So what is the number of what are the lectures they should concentrate on so that that will help them in getting a hang of it. And I said I cannot give any help in this because the course is conducted because I want people to learn number theory, and then I cannot say that okay, you can concentrate only on these videos and it's okay if you ignore the remaining videos. That's not what I'm going to do. So you attend all lectures and see what it gives you. Subhansh is asking what is velocity. My goodness, meaning why should this course talk about velocity? Velocity was, I think, what was velocity? Distance, or what do we call it in physics? Displacement by time. That is velocity. Pavan is asking how important is group theory in number theory? If it is important, what are some examples where number theory uses group theory and how to learn group theory? Okay, so group theory is very important in number theory, and we saw that many proofs became very simple if you use group theory. So for instance, Wilson's theorem is one instance where using group theory has been very useful. And so you may feel that you have not used group theory, you have just perhaps used that a number a, if it is co-prime to the prime p, has some number b such that a into b is 1 modulo p. You may say that you have used only this statement, but this is group theory. So even though you may not have used the word group, but using group is very important. So if somebody knew groups already, then learning number theory will become very simple sometimes. So that's how group theory is very important. And learning group theory is that you pick a book, say Herstein's book, if you are really very beginning student, or Artin's book if you are an advanced student, and go on, read the book and solve problems. Shiv Kumar Kamath is asking, what is the future of a new generations you are in present time? Well, the future is bright, I would say. The future of the new generation is bright, not just in present time, but at all times. No comments. Yes. Then some pointers are given by Soumendra again. Primitive roots, quadratic residues, about assignment solutions with detailed method, and about exam patterns. But I think Soumendra has been active in these lively interactions. So live interactions, they are lively. So I believe that he would have asked his questions. Sangeeta is asking how to find primitive roots. So Sangeeta, finding primitive roots is a difficult thing. There is no method that is known yet. What you should do is do computations. So, it's like finding a generator for a given cyclic group, and there is no known method to do that. That's a very difficult question, and I don't have a good answer to that. Finding primitive roots is extremely difficult as far as my understanding goes. Okay, so that completes the points which were raised for the second live interaction session, and now I have received the points which are put in the Google form for this session. So Arun Kumar is saying, I can't understand. Arun Kumar, if you are online here, please say what is it that you can't understand, and we will try to see whether we can make it simply. Neeti Gangwar, I am like to ask Professor Shripad Garge. Okay, so she is not going to put a question here, but she would rather ask me. And Santu Datta is asking whether is there any application of fixed point theory in number theory, and can we expect an advanced course in number theory in near future? So I think I answered your second question, that an advanced course in number theory in near future should not be expected from me, but maybe somebody else will do it, and maybe you can look up for that. Fixed point theory in number theory, I don't think, meaning if there are any simple solutions. And then somebody is saying that in okay, so Sahiya is again saying about assignment 9, question number 10, 1001 and 1441 to be the correct answers. And I got these numbers can be written as a sum of three integer squares. So the last question in assignment 9 was which numbers are not sums of three squares. It's about which numbers are not sums of three squares. So if you are able to write something as a sum of three squares, then it is not a correct answer because we are looking for numbers which are not expressible as sums of three squares. So therefore, the numbers which you have got cannot be answers to that. So okay. So with that, I think I have completed all the questions that were put to me. I have given some answers. I don't know if they were satisfactory for most of you, but I think we have short our time by quite some margin, and it's time to thank the NPTEL team. So Mr. Sandeep has been helping me with organizing these live interaction sessions, and as always, Bharti Tari and one more Bharti Sankpa at our NPTEL team and the whole NPTEL recording team. They have done great work, and I would like to offer my sincere thanks and appreciation for their efforts. I think there are no questions that I see here, so this is a good time to stop. And my good luck to you all for the final examination, and everything that you may want to do after that. Be in touch. It would be nice to be in touch. Okay, so Danish is asking. Don't worry, Danish. There will be a calculator on that computer. Fourth root of 25. That's just a square root of 5. No, should be easy to get that. Sandeep, I think we can stop here. Yeah.